Hi, this is Esther Park, and I'll be having a presentation about a lab I've done. First, I will have a quick introduction of this video, then talk about important physics concepts that will be used throughout the video. Also, I'll provide a brief preview of the result of the experiments. Then, I'll talk about experiment details and the experiment in detail. Afterwards, I will talk about possible sources of error and answer questions on what if and what does it mean. The purpose of this lab is to compare the predicted motion and the observed motion of the spring mass. Another one is to plot the energy changes that you compute in the model. The main concept introduced in this lab is the law of conservation of energy. According to the law, energy can neither be created nor destroyed. In other words, only converted from one form of energy to another. There are 5 main formulas that were used in this lab. The first one is the velocity update formula, using Newton's second law of motion, and the second one is the position update formula. With the velocity update formula, the change in velocity will be calculated, which will be used in the position update formula to predict the position. The next 3 equations are the equations for energy, which is used to calculate the kinetic energy, spring potential energy, and the gravitational potential energy of the object. This is the brief preview of the object's motion. The system is the spring and the object, and the surrounding is everything else. In this lab, one assumption made is that the air force or air resistance is negligible. The following are the initial conditions of this lab. And this is the code to calculate the change in energy of the object. I set the initial mass, position, initial velocity, spring constant, relaxed length of spring, initial kinetic energy, initial spring potential energy, and initial gravitational potential energy to the values I showed in the previous slide. Then I calculated the net force on the object. Also, I updated velocity and position using the velocity update formula and the position update formula. Lastly, I updated the properties of the spring and I calculated energy changes. When I ran the code, 3 graphs were displayed. The first one was the graph of x position over time, and the second one was the graph of y position over time. And the third one was the change in energy over time. There were similarities and differences shown between the experiment and the computational model of the position over time. For the graph of x position over time, both graphs showed that the mass is oscillating. However, the amplitude of the graph, which represents the range of the x position, was different, and the initial position was different. For the graph of y position of the graph, again, both experimental and computational models showed that the mass is oscillating. However, the amplitude of the graph, which represents the range of the y position, was different and the initial position was different. There are 2 possible sources of error. First, there was a human error because the position of the weight was measured using a tracker. Second, the air resistance was assumed to be negligible, but there it is in real life. There are 2 questions that can be addressed for this lab. First, is the energy principle satisfied? When going back to the graph of change in energy over time, delta E, which is the change in total energy, is 0. This means that the energy has not been destroyed or created. Second, using the data you obtained in Tracker, make 2 separate estimates of oscillation periods. First, by estimating the period of oscillation from the x position data, and second, by estimating the period of oscillation from the y position data. Compare the 2 estimates and discuss. The period of oscillation from the x position data was 1.7 seconds, and the period of oscillation from the y position data was 1.5 seconds. The period of oscillation indicated by these values are different because of the air resistance and other forces that have not considered acting in the x direction and y direction. Thank you for listening to my presentation, and this was Esther.